Hello and welcome to ProSoft's first ever webinar Cagematch. I'm Lauren Robeson-Menting from the marketing team here at ProSoft, and I'll be your host today. Being ProSoft, we focus on industrial communication solutions, and our mission has always been solving automation communications problems in critical applications. While we're a global leader with protocol converters, we have a really competitive industrial wireless portfolio and industrial cellular and cloud connectivity portfolio. And when we work with customers on leveraging these technologies to help solve their problems, there are often questions on when to use wireless Ethernet versus cellular connectivity. This Cagematch will consist of 5 rounds where we will provide some clarity on when to use wireless Ethernet and when to use cellular technologies. In each round, each technology will have the opportunity for one argument, and while we're going to start in a fun way that we can all relate to looking at our personal lives, we'll bring it back to industrial applications and the key considerations for leveraging these technologies to solve our communications challenges. Unlike the recent McGregor fight, we plan on going all 5 rounds, taking roughly 30 minutes. If you have a question throughout the Cagematch, type it into the Q&A box at the bottom of your screen. We'll take on your questions at the end of the match. With that said, let's get started. In one corner, we have Brian from the USA, who will be representing wireless Ethernet. And then in the other corner, we have Vishal from around the world, which is why his accent makes no sense, who will be representing cellular technology. Our fighters will keep their shirts on, and it will be a fair fight, nothing below the waist. If you have a question, type it into the Q&A box at the bottom of your screen, and we'll take on your questions at the end of the match. So let's start round 1 with a basic question. Which technology can you not live without?
Thanks, Lauren. Brian Allport here representing wireless Ethernet, and this is a great question to start with. Imagine this, Vishal. It's a Saturday morning, you're sitting at home, iPad in your lap, doing some research on a new lift kit for your truck, really digging in, trying to understand if you want a leveling kit or a simple 2-inch lift. Your daughters are upstairs messing around on Instagram and your wife is streaming Netflix. Then boom, your Wi-Fi goes out. Your iPad freezes. Your wife is yelling at you. Your daughter's phones just jump off the Wi-Fi and they are a few Snapchats away from going over your data plan. Imagine that feeling in your gut like you just got punched. Losing Wi-Fi gave you that feeling. I think living without Wi-Fi would be pretty tough.
And I would have a perfect solution for that first try from Brian. I'll block that punch by turning my phone into a hotspot. So good afternoon, everyone. This is Vishal. So there you go, Brian. I've solved the problem and everybody's happy. But should I be concerned? You know, I've just added all this load onto my cellular device. Should I be concerned about connectivity issues, specifically losing connectivity? Not really. If you look at the explosion in cellular technologies and services, especially over the last few years, this should not be a concern. The map up there is the 4G cellular coverage map. As you can see, it is ubiquitous. And like I said, 4G has only been around for about a decade or so. Here's a fun fact for everyone. Did you know that the most abundant thing on Earth today, other than the air we breathe, is actually cellular coverage, which is pretty amazing.
Ding, 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 end of round 1. Good, clean fight. Next up, let's go ahead and talk about how this impacts industry.
Thanks, Lauren. This is great. Whether we're talking about the process industry with oil and gas applications, or the infrastructure industry with different types of transportation applications, and especially in discrete manufacturing, like different factory automation type applications, 802.3 wired Ethernet is everywhere. As devices in these applications become more intelligent and everything becomes more connected, Ethernet is the infrastructure for the data that is required to make automation and even intelligent business decisions possible. 802.11 wireless Ethernet is fundamentally the same technology as is wired Ethernet that is becoming ubiquitous in industry. This helps set the stage for wireless Ethernet. Imagine the different efficiencies you can gain by connecting to an application wirelessly. Let's take a water wastewater facility, for example. There's a lot of automation in these facilities, and it's critical that they operate effectively for the health of the local residents and the environment. An example of where wireless Ethernet connectivity can be used here is on the water clarifiers. These are the large circular tanks with rotating skimmers that remove impurities from the water. It's critical that this equipment is able to communicate with the processes before and after it to ensure safe and effective operation. Wireless Ethernet enables this without the cost or the time required to run cables or dig trenches throughout the facility. So Vishal, every time you take a drink of water from your faucet, you can thank wireless Ethernet.
Stated earlier, the explosion in wireless technologies has had a profound and positive impact on our everyday lives, whether it be turning on the faucet, like Brian said, or filling up the gas in your car. And the success, or the key to all of the success, is communications. And this has been true since the dawn of time, whether we're talking about Middle Earth, as you can see from the image, or in industrial applications like manufacturing and utilities. Now, Brian did put up a good fight for the use of wireless in discrete manufacturing, and I agree. But what if those assets that you want to communicate with are remote, assets that are spread over a large geographical area? Let's take the case of a pipeline, an oil and gas pipeline. Pipelines typically go for many miles and cross many geographies. Real-time communications to the control and monitoring systems on these pipelines is super critical for two reasons: knowing current state and for safety. And today, with all of the smart instruments and devices that you have at these remote locations, they provide more than just a on-off status. To bring back all of that information, you need a reliable connection. This reliable connection is also required for forward control because it allows the operators to remotely manage their system without having to spend hours on the road or being in close proximity to hazardous locations all the time. And this is where cellular as a mode of remote communications has been very reliable and secure, fundamentally given the ubiquitous nature of cellular coverage. So similarly, if you look at sort of a local water, wastewater type utility, a municipality, they're providing a service to their community, and their assets are spread over a large area. Real-time control and monitoring of these assets is critical to ensure, like Brian said, that when you turn on the faucet, there is water, and when you flush the toilet, it works correctly. So automation in these processes is complex and happens in near real time. To be successful, a reliable and secure connection is utmost.
Ding, ding, ding. That's the end of round 2. Going into round 3, I think I'm going to need another example of the impacts on industry.
Okay, Lauren, no problem. Let's dive into factory automation. You know what? Let's picture this automotive manufacturing facility. These facilities are massive and automation is everywhere. You've got just-in-time parts being delivered and put onto different types of conveyors. Conveyors interlocking with each other, one picking up where the other drops off. And we have hundreds of workers spread across hundreds of work cells, putting everything together. Every single step in this process needs to be connected and communicating. With so many moving parts in an environment like this, some pieces of equipment must be connected over wireless Ethernet. It's the only option. These could be the autonomous carts that help deliver the just-in-time parts to the assembly line, or it could be the autonomous vehicles that are integrated into the assembly line, or it could even be the fixed conveyance systems. All of these different pieces of the plant need to be connected, and that just wouldn't be possible without wireless Ethernet. There are a lot of things that are important in an environment like this: safety, speed, reliability, but one of the most valued is uptime. I've heard numbers in this industry suggesting that a single minute of downtime in an automotive manufacturing facility costs over $10,000. I really think, Vishal, you can thank wireless Ethernet for reliably enabling the connection and communication required to manufacture the affordable vehicles that we all drive every day.
Yeah, I would have to agree with you on that, Brian. I think the one thing we can agree on is certainly the changes in wireless technologies over the last decade, which has been and continues to be quantum in nature. As a second example, let's look at OEMs. OEMs, or original equipment manufacturers, are critical in industrial automation. They bring in specialized skill sets that are generally not present within the organization. And OEMs typically have a small footprint and are nimble. Now, this means that they have to be efficient with their resources, including support. The two most important things for an OEM are making sure their customers minimal downtime, as Brian said, or maximum uptime, and to reduce their own support costs, which obviously adds positively to their bottom line. So to do this, they need to have a secure and reliable connection to their service location. And they can do this either one of two ways. They can give them, end customers can give them VPN access, or the OEMs can include a cellular gateway as part of their machines for remote connection. End customer VPN access is often a challenge. And in many instances, customers are not willing to do this because of potential security vulnerabilities. So cellular remote access remains probably the next most viable option. And since OEMs and their customers can be on different continents, the cellular connection makes financial sense, because a site visit can cost many thousands of dollars, not to mention the increased downtime. When you compare this to a safe and secure managed remote access, the savings for the OEM and their end customers are significant.
Ding, 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 that's the end of round 3. What I think I need to hear around 4 is some real meat on when you need these technologies.
Okay, Lauren, that's a great question. We already talked about a few examples in the industry when we could use wireless Ethernet. You may be able to tell that it is best used in applications that require real-time communications. This is at the control level and the device level of a network. The control level is where your automation application lives. You have an industrial controller talking in industrial protocols like Ethernet IP to devices. These devices may have their own device level network where wireless is used to send IO data or SIP data back to the control network. In applications like this, there are a few steps that are required to really optimize this wireless network. It is critical to have line of sight between the antennas. This helps to make sure you don't drop packets, ensuring successful data transmission, allowing your automation to keep operating effectively. Next, it's important to make sure you're using a wireless channel free of other wireless networks. Wireless Ethernet utilizes 2 unlicensed bands, 2.4 and 5 gigahertz. In 2.4 gigahertz, we have 3 non-overlapping available channels that we can use. And then 5 gigahertz, we have 9 non-overlapping non-DFS channels that we can use. This gives us a total of 12 channels to work with, which is great. Next, you want to verify you have a strong signal strength. And if you follow the first 2 steps effectively and use the correct antenna, this step is pretty easy. And now we want to make sure we are managing the traffic that is sent wirelessly. Just like in a wired network, it's important to minimize unneeded broadcast packets in favor of unicast packets. And the great thing about wireless Ethernet, especially from ProSoft, is that it's possible to hire an expert to help you with all of these steps and ensure a successful application. Off to you, Vishal.
I'll give you that, Brian. You certainly would not want to use cellular within a plant environment. Take, for example, like a bottling plant. You wouldn't want to use cellular within that plant. It's in a closed environment, where you want to connect different parts, machines to the plant. But if you take that same bottling plant, they most likely will have like an independent contractor who would supply the raw materials required. The user could just have this supply company come in and deliver the raw materials periodically, even if they're not required, which obviously would be pretty inefficient. But let's say, for example, that same supplier, if they've got access to real-time information, so they can schedule their deliveries better. So they've got information on usage and what type of raw materials are required, that will allow them to schedule their deliveries accordingly. And in that scenario, a cellular wireless connection is ideal from a supplier standpoint, because it then provides them independent access to real-time information that will allow them to be more efficient in their delivery schedule. And for the end customer, having the supplier have access to that real-time information is more efficient, because they're not getting materials that they may need. And at the same time, they're not compromising their own network, because they don't have to give access to that supplier to their internal industrial wireless network. So for applications that require wide area coverage, like infrastructure, if you look at the total cost of operations, sort of over a 5-year period, you'd find that cellular comes to be 30% cheaper. Imagine having no card studies, no high-profile antennas, and if you combine this sort of with a safe, secure, and managed service like ProSoft Connect, you have this perfect combination of simplicity, reliability, and security, where ProSoft Connect is this cloud-native managed network to connect all of your remote assets. So as Brian said, ProSoft is here to help you with whichever technology you use and ensure that your application is successful.
Ding, 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 that's the end of round 4. So this is going to be the final round. It's been a really good, clean fight so far. Talk to me about what the future holds for these technologies. What can we all expect?
This is a great question for the final round. It's no secret that wireless Ethernet is becoming more and more important for us in the future. The great thing is that this is a technology that is continually being developed and made better. An example of this is 802.11ax, or Wi-Fi 6. This is a brand new technology, and the IEEE work group is scheduled to ratify the standard very soon. This new wireless Ethernet technology is going to enable wireless applications that we can't even imagine today, truly next-gen applications. These next-generation applications are going to have a need for increased capacity and increased reliability for the deployment of more dense networks. It's clear once this technology is available, we will only rely on wireless Ethernet more.
As for cellular wireless, well, the 5G rollout is just beginning. You already saw the 4G coverage map, which is pretty ubiquitous, but service providers are just rolling out 5G, and they're already talking about 6G. So this is certainly a very exciting time to be in the cellular wireless industry. But what does all of this new technology mean for industry? You have the obvious advantages, the increased speed and bandwidth, along with better security and reliability. But this new technology, the 5G, the bigger advantage for industry is going to be with edge computing. Today, most data is sent to a central location for processing and analysis. the advent and the implementation and the proliferation of 5G is going to change that. Imagine being able to process data at the edge and only send what is absolutely required to the central location. This will lead to increased efficiencies, and with more devices being connected, that's going to be paramount. The decrease in latency combined with the increase in bandwidth and speed means that more applications can take advantage of this 5G technology. Another advantage of 5G is that every device is designed to become almost like the microcell sort of a mini transmission that tower by itself. So this will also help increase the reliability of 5G. Now, this is not to say that 5G will be the only answer that will solve all of the communication problems. As you've seen today, both wireless and cellular technologies offer significant connectivity advantages. And the selection of a type of connectivity does depend on the application. What is true is that communication continues to be paramount to increase both efficiency, productivity, and safety of your industrial automation applications.
Ding, ding, ding. Wow, that was a great match. Good job, guys. It seems like both wireless Ethernet and cellular technologies have a place in our lives. And I think it's clear that we rely on both of these technologies today, and they'll both only become more important for us in the future. Seems the secret is to define how we can leverage both of these technologies to better enable our applications. If you need any support in trying to better understand how either of these technologies could create efficiencies in your applications, ProSoft is here to help. And with that said, we'll go ahead and check the questions box now to see what you think. And if you do have any questions, make sure to type them in. We'll give it a couple minutes too on there. Well, it's looking like no questions so far. So we wanted to say thank you everyone for attending ProSoft's first Cagematch webinar. We'll be sending you the recording in the next few days. Please make sure to let us know what you thought of the fight. Oh, actually, we do have a couple now. Sorry. One of them is, guys, which band is better now for Wi-Fi, 2.4 or 5?
I could take that one.
Oh.
So the answer based on your application could be different. Most indoor applications with other wireless networks, 5 gigahertz is preferred. But if you have an outdoor application, such as that wastewater facility, and there's no risk of other wireless networks, and you need the signal to go a little further, 2.4 is preferred. But it'd be,
okay, cool.
it'd be good to ask a local expert based on what problems you're trying to solve.
Cool. And we have a question here about devices communicating with cellular and wireless 2.4 together.
So is the question, can you have both types of technologies in a single network, or is it a single device communicating using both technologies at once?
For both.
Just for both, okay. So you can certainly have both types of technologies in a single network. So say, for example, if you take a municipality that's got assets spread over a large area, it's very well conceived that they could have part of the system on wireless communicating back to a central location, and then perhaps all of those hard to reach sites, ones that are further away, could be on the cellular. So you could have both technologies on a single network. As to devices supporting both technologies, so a single piece of hardware supporting both wireless and cellular, that does not exist today as far as I know, primarily because these are two very different technologies with different capabilities. So you would need two pieces of hardware for that.
Okay, cool. If anyone else has a question, please type it in now. Otherwise, we'll end in about a minute here.
Lauren, another question has come in. Brian, I think we'll take this one. When to use a MIMO antenna?
Okay, MIMO antennas would be best used in applications where you might have a lot of obstructions, and there's a risk for the wireless signal to bounce off of several different walls. So MIMO, multiple in, multiple out, increases the reliability of the receiving antenna in an application like that. So inside a factory, for example, is good for MIMO, and most likely your home wireless system is MIMO antennas because of all of the obstructions in your house.
Cool. Okay, does anyone have any other questions? If not, I think we'll probably just go ahead and end this here then. Thank you everyone for attending our first ever Cagematch webinar. It was fun to have, and we hope you had a great time. Make sure to keep an eye out for the email with the recording in the next few days. Thank you.